All right, we're going to solve this using the method of Laplace transform. So what we do is we take the Laplace transform of y double prime plus 5y prime plus 6y on the left, and Laplace transform of 6u2t unit step function shifted by 2. Some people write this as u of t minus 2. I sort of prefer that, but anyway, using linearity, we get ly double prime plus 5ly prime plus 6ly equals 6. The Laplace transform of this piece right here, u2t, is e to the negative 2s over s. And then I have formulas for this y double prime. We have s squared y minus sy of 0 minus y prime of 0. Then for ly double prime, we have sy minus y of 0. So that's this part right here. It goes here. And then I have 6y equals e to the negative 2s, 6 over s. So I like to keep the negative e to the negative 2s to the side. Now, these parts here where I have y of 0, y prime of 0, those are our initial conditions. And they were chosen to make this problem shorter to be 0, just to... So, yeah, it's maybe a little bit of... I don't know if it's a cop-out. It's just the problems get super long. So I'm just trying to shorten it a little bit by making it a little easier. Except here I made a typo mistake there. So I have s squared plus 5s plus 6 times y equals e to the negative 2s, 6 over s. So y is equal to e to the negative 2s, 6s s squared plus 5s plus 6. And so that, this guy right here factors. So this is s plus 2, s plus 3. So that is something we can factor. We've done other problems where it does not factor. One way you can do this then is you can write this as y equals e to the negative 2s g of s, where g of s is equal to 1 over s plus 2, s plus 3. And we have a formula that says that Laplace transform of the unit step function at f of t minus a, maybe I'll just put g since I'm using g here, g of t minus a is equal to e to the negative as gs. All right, so going backwards then, if I find the inverse, which is what I want to do, I want to get the inverse Laplace transform. This is going to be u2t g of t minus 2, all right? So the thing is, well, then I'm down to the question, which isn't really maybe that bad, but maybe it is, of finding the inverse of capital G here. So we're going to find g of t. So g of s is equal to, again, 1 over s plus 2, s plus 3, and that's a over s plus b over s plus 2 plus c over s plus 3, where we're using partial fractions. Okay, so we're using partial fractions there. And so the idea now is that, you could even sort of skip ahead, but you can find the Laplace transform inverse Laplace transform of each of these, sort of easy actually. It's just, anyway, well, it's e to the, like this first one is 1, and the other one's e to the negative 2, e to the negative 3t. So those are not that bad, but we have to find a, b, and c. So what I do is I multiply through by the common denominator. And if you haven't done these, then they seem sort of like maybe a lot, but once you get rolling on them, it becomes way easier. And then what you do is you put in values for s to kill some of the terms. So say I put in, just the first thing I saw there, for whatever reason, I put in -3. So 1 is going to equal 0 plus 0 plus c times 3, -3, -3 plus 2. So see, putting in -3 will kill the s plus 3. And that's why I put -3. So 1 is equal to -3 times -1. So c is 3c is equal to 1. I'm sort of thinking I made a mistake. Yeah, I did. It's like, well, I tried to pick numbers. So I started to make this whole thing distracting. I tried to pick numbers where so I wouldn't get fractions. So it's actually a 6 here. That might have been distracting throughout. That's a 6. Okay, so this is 6. It's just these little things that I don't think I'm the only one, but maybe I make these little mistakes, and it just, and there's so many little pieces where I have to pay attention, and if I don't, then redo the problem or something. Okay, let's try s is equal to what's another convenient number. Put in s's, say -2 right there. That'll kill a and c term. So s is -2, and I'll get 6 equals 0 plus b, -2, -2 plus 3 plus 0. So 6 is equal to b times -2 times 1. So -2b equals 6, so c equals -3. Oh my gosh, well, I'm thinking, if I made that mistake, did I make another mistake? But gotta just keep going, not lose my confidence here. All right, and then let's pick another number. So let's pick s is 0. That'll kill the b and c term, and I'll be able to solve for a. So s equals 0 gives 6 equals a, 0 plus 2, 0 plus 3, plus 0 plus 0. 6a is equal to 6, so a is equal to 1. Got that. So again, then g of s, copying and pasting, just what I have up there, is going to be 1 over s. Oh, gosh. I wrote c equals -3. How annoying for anybody watching the video. This b is -3. Okay. 1 over s minus 3 over s plus 2 over s plus 3. Little g of, okay, now Laplace transform of e to the at is 1 over s minus a. Then I'll just write this down. It's the same thing, really, just a slightly written form, different form. E to the negative at has Laplace transform of 1 over s plus a, and Laplace transform of 1, which would be when a equals 0, is 1 over s. So therefore, little g of t is Laplace inverse of 1 over s, which is 1, minus 3, Laplace inverse of 1 over s plus 2, which is e to the minus 2t, Laplace inverse of 1 over s plus 3, which is, or there's a 2 there, 2 e to the negative 3t. And then y of t is equal to, if you remember, we go all the way up there, y of t is equal to u2t gt minus 2. So almost done. So y of t is equal to u2t 1 minus 3 e to the negative 2, 2 minus t, plus 2 e to the negative 3, 2 minus t. And anyway, it's hard to check the answer. It satisfies the initial condition of y of 0, y prime of 0 equals 0, because this function is equal to 0 all the way up to 2. But to take the derivative is something we haven't talked about yet. So anyway, okay, so we'll stop there.